What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 9, Section 5, Solving Trigonometric Equations. Let's do it. So question 1 asks, will there always be solutions to trigonometric function equations? If not, describe an equation that would not have a solution. So I would say definitely there are situations where you're not going to have a solution. And that's going to be, for example, let's say you have sine of x equal to 7. So this is one example where this is not going to have an answer. The reason why is because 7 is outside of the range of sine of x. You're only going to get values between -1 and 1. When solving linear trig equations in terms of only sine or cosine, how do we know whether there will be solutions? So the idea is, if we remember that sine of x and cosine of x, just two in particular, they have ranges between -1 and 1. So when you isolate it and you're setting it equal to a value, for example, if the value is 1/4, we know we're going to get a solution because that's within the range of -1 to 1. And same with cosine. If we had 1/2 or something, or even -1/2, that'd be okay. But as soon as we isolate sine or cosine, and let's say now we're setting it equal to like -4, that's outside of the range of sine. So in this case, we know there won't be a solution. So anyways, that's how you can determine it. Done. So for this one, first I'm going to isolate sine of theta by dividing both sides by 2, and then I get sine of theta equals rad 3 over 2. Then I'm going to look at the unit circle. We're saying sine of some angle is rad 3 over 2. Remember, sine of an angle on the unit circle corresponds with y values, right? So where are the y values equal to rad 3 over 2? Right here and right here. Positive, by the way, right? So we actually have two solutions between 0 and 2 pi. We have pi thirds, and we also have 2 pi thirds. So those are solutions. Done. So for this one, we're going to start by dividing both sides by 2, and we get cosine of theta equals -rad 2 over 2. So now we're in a situation of what angle is going to give me this output for cosine. Now, we're looking at the unit circle. Cosine links up with the x values on the unit circle. So where do I see -rad 2 over 2 for an x value? I see it here, and I see it here, which means we have two answers between 0 and 2 pi. I have 3 pi fourths and 5 pi fourths. So 3 pi fourths, 5 pi fourths are the answers for theta. Done. For this one, we're solving for x, and we're saying tangent of x equals 1. So really what we're trying to say is for what angle measures are we getting a value of tangent that's 1? And remember, tangent is y divided by x in the unit circle. So where basically are the values going to be the exact same? I see it here, right? At pi fourths, they're going to be the exact same. We're going to have 1. And also here at 5 pi fourths, they're the exact same. We're going to have 1. So my answers for x are pi fourths and 5 pi fourths. That's how you do it. Done. So this one, we're going to start by adding 2 to the other side. So we got 4 sine squared x equals 2. Then we're going to divide by 4. And of course, 2 divided by 4 is the same as 1/2. So we got 1/2. Now, this is sine squared. I need to take the square root of both sides. That's going to give me regular sine of x is going to equal plus or minus radical 1 over 2. Now, I can simplify this radical, right? I can make it square root of 1 over square root of 2. Square root of 1 is just 1. Square root of 2 is square root of 2. Then rationalize that denominator as we're supposed to do, right? And you're going to see something familiar. We got rad 2 over 2. Again, this is plus or minus. So we're saying sine of some angle is equal to both positive and negative rad 2 over 2. Now, if we look at the unit circle, if you remember, sine corresponds with the y values on the unit circle. So where do I see either positive or negative rad 2 over 2 in the y value? I see it here, 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 and here. So what are these values? We got pi fourths, we got 3 pi fourths, we've got 5 pi fourths, and last but not least, we got 7 pi fourths. So those are the 4 answers. Done. So for this one, we're going to start by isolating by dividing both sides by 2. So I have cosine of theta equals rad 2 over 2. Now, this is saying cosine of some angle is rad 2 over 2. Looking on the unit circle, cosine links up with the corresponding x values. So where do I see rad 2 over 2 as an x value? I see it here, and then I also see it here, because it's got to be positive. And what are those two theta values in radians? We got pi fourths, and then we have 7 pi fourths, everything between 0 and 2 pi, of course. That's how you do it. Done. So for this one, I'm going to start by dividing both sides by 2, and then I've got sine of theta equals -1/2. Now, knowing sine corresponds with y values, I want to see which of these coordinates has negative 1/2 as a y value. So I got negative 1/2 for the y occurring here and occurring here. That's 7 pi 6 and 11 pi 6. So those are my two answers, 7 pi 6 and 11 pi 6. Boom, done. So for this one, we're going to start by dividing both sides by 2. And then I have sine of 3 theta equals 1/2. Now we're going to take it to the point where we need to figure out what values on the y value coordinates are going to give us 1/2, because sine corresponds to y values. So I got 1/2 here, positive mind you, and 1/2 here. So that means that this angle, 3 theta, equals pi over 6 and 5 pi over 6. But we're not done, because this is what 3 theta equals. I need to know what theta equals, which means I have to divide both sides by 3. So then theta equals pi over 18 and 5 pi over 18. Now here's the deal. We're trying to get every answer between 0 and 2 pi. So if we didn't divide by 3, these would be the only two answers, right? But the thing is there's actually more because we're dividing by 3, right? So what we can do is we can kind of come back to this point and say pi 6, 5 pi 6, right? But then every coterminal angle to pi 6 and 5 pi 6 are also going to be legitimate answers. Again, beyond the scope of 0 to 2 pi, but I'm going to show you how it relates. So if we have pi 6, I can also add 2 pi to that and make it 13 pi 6, right? 12 over 6 is the same as 2 pi, right? So 13 pi 6. And same with this one, that would be 17 pi 6. And then we can do it again. 13 pi 6 is coterminal with 25 pi 6, adding 12 over 6 pi, right? And then this one would be adding again, it'd be 29 pi over 6. And again, both of these, or all 4 of these, I should say, will have to be divided by 3, because these are all potential values of 3 theta. So we're going to stop here, and I'm going to show you why. It's going to make sense once I finish this. So all of these divided by 3 then become 13 pi over 18, 17 pi over 18, 25 pi over 18, right? Dividing by 3 is like multiplying by 1/3. And then 29 pi over 18. Now, I'm not going to go beyond this, because I'll show you what's beyond this, right? After 29 pi, or 25 pi and 29 pi, I'm going to add 12 to that, and I get 37 pi over 6. When I multiply by 1/3, I'm going to get 37 pi over 18. But 36 pi over 18 would be 2 pi. This is beyond 2 pi. So now we've gone too far, right? Now this is not included from 0 to 2 pi. So we stop there. So these are our answers. These 6 solutions are viable options for theta. Done. For this one, we're going to start by dividing both sides by 2, and then we get cosine of 3 theta equals rad 2 negative over 2. So now we're looking for every spot, okay, on this unit circle where the x coordinate is going to be negative rad 2 over 2, because cosine links to the x coordinate. So I got negative rad 2 over 2, negative rad 2 over 2. So my two answers are 3 pi fourths and 5 pi fourths, okay? But this is what equals 3 theta. This is not theta, so we still have work to do. But before we do that, I'm going to do a couple of other things, right? I know that we're going to have more answers than normal, because we're really solving for something that's being multiplied by 3, right? So for the answer, for the angle values that we're finding, there's going to be more than just 2 that are going to be within 0 to 2 pi. So what I'm going to do is I'm going to write out a few more, because if 3 pi fourths and 5 pi fourths are answers, anything that's coterminal with these guys are going to be legit as well. So if I can add 2 pi to both of these, right, 2 pi would really be 8 pi over 4. That would be 11 pi over 4 and 13 pi over 4, and do it again. Then we get 19 pi over 4 and 21 pi over 4. I'm going to write one more just for fun, which will be the next one up, which would be 27 pi fourths. Okay, so anyways, these all equal 3 theta. Now to get theta, I have to divide all of these by 3. So dividing this one first, this one becomes 3 pi fourths divided by 4, or 3 pi fourths, sorry, times 1/3, or divided by 3. It just becomes pi fourths, okay? This one becomes 5 pi twelfths, this again multiplying by 1/3. This one becomes 11 pi twelfths. This one becomes 13 pi twelfths. This one becomes 19 pi twelfths. And this one becomes 21 pi 12. So now let's go to this next one, right? This one would be 27 pi 12. But here's the issue. 27 is more than double 12, which means this is greater than 2 pi. So we're going to stop here. And then these 6 are going to be our viable answers. So that's how you do it. That's how you solve for theta. Done. So for this one, we're going to start by dividing both sides by 2, and then we have sine of pi theta equal to 1/2. All right, so where or what angles do we get 1/2 for sine, meaning where do we get 1/2 on the y values, right? I get 1/2 here, and I get 1/2 here. Again, we're trying to find positive, so we can't include the negatives, right? So what are the two angles? That's pi 6 and 5 pi 6. So we got pi times theta equals pi 6 and or 5 pi 6. Now, anticipating pi is, pretty close to 3 times theta, I'm anticipating that I'm going to have triple the amount of normal solutions. So instead of just 2, I'm anticipating 6, maybe 7. So we're going to add a few more. And remember, we can do that by just adding coterminal angles to these existing ones. So pi 6, I can add 12 pi 6, that's 2 pi, keep adding 2 pi, right? So I got 13 pi 6, and then I've got 17 pi 6, and then I've got 25 pi 6, and then I've got 29 pi 6, and let's do one more just for good measure, and then we'll have, adding 12 to that is 37 pi 6. Okay, then all of these now need to be divided by pi, okay, to get theta, because this is pi times theta, so divide them all by pi. So this one divided by pi becomes 1/6, this one becomes 5/6, this one becomes 13/6, this one becomes 17/6, 25/6, 29/6. Okay, let's take a pause here. So we've got 29/6, by the way, which is pretty close to 5. So that's still under 2 pi, right? 2 pi is about 6.28. And then we've got this one here, which is 37/6. Now, 37/6 is interesting because that's 6 1/6. And 1/6 is roughly 0.17. So this would be like 6.17. That's still under 2 pi. So this is actually legit. We could go one more, but we know we're going to surpass 6.28 or surpass 2 pi. So these 7 would be the final answers for theta. That's how you do it. Done. For the following exercises, find all exact solutions on 0 to 2 pi. So we got secant of x, sine of x, minus 2 sine of x equals 0. So first what I'm going to do is I'm going to factor out sine of x. I see I have sine of x in both spots. So I have sine of x times, and then I have secant x minus 2 equals 0. So this is great because now I have two viable possibilities, right? I have when does sine of x equal 0, and also when does secant minus 2 equal 0. Well, then I can add 2 to both sides for this one. When does secant of x equal 2? So this is interesting because cosine and sine, right, they go from -1 to 1. So this would be a no solution if it was sine or cosine, but secant can go to 2, all right? And if you remember what secant is, it's the reciprocal of whatever you're going to get for cosine, which means we need x values on this unit circle that are going to have a reciprocal value of 2, aka 1/2. So I got 1/2 here, and I also got 1/2 here. That means my two values for x are pi thirds and 5 pi thirds, okay? And then for sine of x equals 0, what value of x or what, theta value or whatever is going to give me a sine output of 0? It's right here and right here because sine corresponds to y. So we have 0 radians and pi radians. So we also have 0 and pi. So those are your 4 solutions done. So for this one, we're going to start by setting everything equal to 0. So I'm going to subtract 1 from both sides, and then I've got 2 cosine squared t plus cosine of t minus 1 equals 0. Now what I'm going to do is I'm going to see if I can factor this because this looks like a quadratic, right? And since we have a leading coefficient of 2, I'm going to use the star method. And what we're going to do is we're going to place that a term here, right? This is a, b, and c. A times c, 2 times -1, -2 goes on top, and then 1, right, the coefficient in front of cosine 1 goes on the bottom. So then the question is, what two numbers multiply to -2 add to +1? That'd be +2, -1, cancel, cancel, 1, 1. All right, now we have the values to factor this correctly. So 1 goes with the variable on top, right? Because that's typically what happens, but here our variable is cosine t. So we got 1 cosine of t, and then that's +1, right? That 1 is a +1. And then over here we have 2 cosine t. Top number goes with the cosine. Bottom number is the constant, like this, and then this equals 0. Now we can create our two equations because we can kind of split it up. We're trying to figure out when this is going to go to 0 and when this is going to go to 0. That's going to create two separate sets of solutions. So first we've got cosine t plus 1. When is that going to equal 0? Subtract 1 from both sides. Cosine t equals -1. If you remember, cosine relates to the x values on the unit circle. So where do we have -1 for the x? Right here. Okay, so it's just one spot, and that's going to be a value of pi. So one option is t equals pi. The other one is 2 cosine of t minus 1 equals 0. I'm going to add 1 to both sides. 2 cosine t equals 1. Divide by 2. Boom. So cosine of t now is equaling positive 1/2. When does that happen? When is the x value 1/2? Here and also here. So we have two more solutions, right? We have pi thirds and 5 pi thirds. So we have pi thirds and 5 pi thirds. And they said just from 0 to 2 pi. So it's everything from 0 to 2 pi. 3 solutions. Boom. Done. So for this one, what I'm going to do is I'm going to do a little factoring by grouping. Okay, so I see these two here, and they both have a sine of x. So I'm going to factor out sine of x first. And I'm left with 2 cosine x and then -1 because I'm pulling that entire sine from the sine. Now, the reason why this is cool is because, look, I have 2 cosine x minus 1 here. And the way I'm going to write it is I'm going to put a 1 in front of 2 cosine x minus 1. And that's fine because anything times 1 is just itself. Now I can do my factoring by grouping because I have this and this in two places. So I can pull that out. Let's say I have a little bit more room. And then I have 2 cosine x minus 1 pulled out. And then I have sine of x plus 1 left in the other parentheses. That's how factoring by grouping works. Now we've got this all equal to 0. Now I'm going to break it up individually into two different equations because I want to know when this equals 0 and separately when that equals 0. So first, 2 cosine x minus 1 equals 0. Then I'm going to add 1 and divide by 2. So when does cosine of x equal 1/2? Again, cosine links with the x values on the unit circle. So 1/2 here and here. So we've already got two values. We've got pi thirds and 5 pi thirds, okay? And then what about this equation? When does sine of x plus 1 equal 0? AKA, when does sine of x equal -1, right? Sine of x plus 1 equals 0, subtract 1. So when does it equal -1? And sine is related to the y values on the unit circle for these coordinates. So where do I see -1? Right here, one spot. And that's an angle of 3 pi over 2. So these are the three solutions. Done. For this one, I'm going to start by taking the square root of both sides, and then I get secant x equals plus or -1. It can be either. Okay. Now, if we remember what is secant, it's the reciprocal of whatever you get for cosine. So really what I'm thinking about is for what x values on the unit circle will the reciprocal equal positive or -1? Well, it's going to be wherever it equals 1 or -1, right? The reciprocal of 1 is 1. Reciprocal of -1, -1. So I got two spots. I got here and here, and the corresponding angles are 0 and pi. So my answer for this one is 0 or pi radians. Boom, done. So for this one, really, we have a quadratic, right? It's the same as if you had 8y squared plus 6y plus 1 equaling 0. It'd be the same thing. So here we have a leading coefficient. We're going to have to use the star method if this is factorable. If it's not, we're going to have to use the quadratic formula. So I'd have the a term here, a times c up here, and 6 down here. Then we ask the question, what two numbers, if any, multiply to 8 and add to 6? Well, we do have two. It's 2 and 4. And then we can reduce this like a fraction. 8 over 4 reduces to 2 over 1. 8 over 2 reduces to 4 over 1. And then these are the values for the factoring. So then we have the top number is a coefficient with the variable. The bottom one is the standalone constant. Now, if it was y, it'd be 4y plus 1. But our y is really sine of x. So it's 4 sine of x plus 1, and then over here it's 2 sine of x plus 1. And this is all equal to 0, so now I can get my two equations. First I have 4 sine of x plus 1 equal to 0. Subtract 1 and divide by 4. Let's do that in one step. So sine of x equals -1/4. Over here, we'd have 2 sine of x plus 1 equals 0. We'd subtract 1, simultaneously divide by 2, which means sine of x equals -1/2, right? Subtracting 1, dividing by 2. All right, so remember, sine on the unit circle corresponds to the y values of the coordinates. So first we have -1/2, where do I see that? I see that here, and I see that here. Okay, so that's 11 pi 6 and 7 pi 6. So 7 pi 6 and 11 pi 6. Okay, what about -1/4? That's an issue because -1/4 is not on the unit circle. Okay, so, and they didn't give it to us in the back of the book as an approximation, like you can just put it into decimals. So we have to take arc sine of both sides, and then we get x equals arc sine of -1/4, okay? And, we're talking about these negative values. So if you remember, the domain for arc sine is going to be from -pi halves to pi halves. So it's going to give us something in this region, right? Because we're taking sine of a negative. So whatever this angle is, and by the way, that's going to be a negative angle. So we want something from 0 to 2 pi. So I want the coterminal angle of this. So one of my answers is going to be inverse sine of -1/4. But again, because we're in this like negative region, I'm going to add 2 pi to bring it back into a positive value between 0 and 2 pi. So this is another answer. Now, but the thing is, if I have a value here, I'm also going to have a value in this quadrant. That's a symmetry property of sine. Like, think about it. If I have a -1/2 here in the fourth quadrant, I also have one here in the third quadrant. If I have a negative rad 2/2 here, I have one here. So we know we're also going to have a second value in the third quadrant. So the way I can go about finding that is it's taking this giant angle, whatever it is, right? What I'm going to do is I'm going to subtract it from 2 pi. And if I do that, I'm going to get some angle up here in like the first quadrant, okay? And then to get it to that mirrored angle in the third quadrant, I have to add pi to it. So it's a two-step process. So first I'm going to take this that we have, and I'm going to subtract it from 2 pi. And when I do that, I'm going to distribute this, and the 2 pi's are going to cancel out. I'm left with negative sine of -1/4. And then to that, I'm going to add the pi, right, to bring it into the third quadrant. So then my last angle is going to be inverse sine negative of -1/4, and then all of this plus pi. Okay, so that's pretty complicated, but that's how you do it. So here are 2 of the answers. Here are the other 2. That's how you do it. Done. So for this one, when I look at it at the start, this definitely looks like a sum difference identity, right? Sine, cosine minus cosine sine. That looks like this. That looks like sine of x minus y. So I can rewrite this as sine of x minus y, right? The first term minus the second term. So 3x minus 6x is -3x. So we can simplify this down to this. The other thing I can do is, because sine is an odd function, I can basically say sine of a negative argument is the same thing as negative sine of that positive argument. This means the negatives cancel out like so. Then what I can do is I can take arc sine of both sides. I can say 3x equals arc sine of 0.9. Okay. So here we have our first example of one of the potential solutions, arc sine of 0.9. But here's the thing, we still have that equaling to 3x. And also, this is going to give us a nice answer in that first quadrant, okay? So we know that with sine, there's going to be an answer in the first quadrant, but also the second quadrant, because sine is y. So if it's a positive argument, we've got positive signs in the first and second quadrant. So if this is going to give me one answer, we've also got another answer, okay, in that second quadrant, which can be found by taking this angle and subtracting by pi. Okay, so now we got 2 angles. Now, typically, this is all we'd get from 0 to 2 pi. But again, because it's equal to 3x, we're actually going to get 3 solutions. So the way to think about this is you take your existing solutions that we just found here, 1 and 2, and then let's get coterminal angles going up to 6 pi. Okay, that's 3 times 2 pi, right? So we're going triple the normal amount. So I got this and this. Then I have arc sine of 0.9 plus 2 pi. And then I have this one plus 2 pi as well, which 2 pi plus pi will be 3 pi. And then I got 2 more solutions, which will be coterminal to these 2. So again, add 2 pi, so that's going to be 4 pi. And one more adding 2 pi to this, which will make it 5 pi minus arc sine of 0.9. Now with every single one of these solutions, since they all equal 3x, I'm going to divide all of them by 3. So what I did is I took all 6 of these answers and I divided them all by 3. So these are the solutions. It's a slightly different format than in the back of the book, but it's exactly equivalent. So this should be all good by pretty much any teacher, but just double check it with your teacher, make sure you have it formatted the way they want, but that's how you do it. Boom, done. So for this one, what I'm going to do is I'm going to use my double angle identities to simplify and then solve. So first of all, cosine of 2x. The one I'm going to use here is this one, 1 minus 2 sine squared x. And there's a reason why. You'll see when we plug this one in, because when I plug this one in, I have no choice, right? Sine of 2x, I only have one option, 2 sine x cosine x. So you're going to see why this is going to simplify nicely. So I plug it in, so I replace cosine of 2x with 1 minus 2 sine squared x. And then I'm going to distribute, and then I get cosine of x minus 2 sine squared x cosine x. Okay, and then when I plug in 2 sine x cosine x for this, we get 2 sine x cosine x, and then another sine of x, which is basically going to multiply against this existing sine of x, which is going to make that squared. Okay, so now look how nice this is. I got minus 2 sine squared x cosine x plus 2 sine squared x cosine x. Guess what? Cancel, cancel. And this all now equals 1. So we got cosine of x equaling 1. Now we go back to the unit circle. When does cosine of x equal 1? Well, that's whenever the x value of these coordinates is equal to 1. Cosine corresponds to the x value. So the only place where I see that is right here, which means we only have one solution for x, which is 0 radians. So 0 is the final answer. Done. So for this one, I'm going to start by using a double angle identity. And since I see cosine of 2 theta, I'm thinking of using this one because it only has cosine on the other side, so that's going to make it as easy as possible. So now I'm substituting 2 cosine squared x minus 1 in for cosine of 2 theta. And by the way, I'm going to use x because I just think it's easier to write x. So let's do that, and just know that, hey, it's just a variable. It's the same thing as kind of theta. I just don't like to write theta. Next, we're going to distribute, and then I got 18 cosine squared x minus 9 equals 9 cosine squared x minus 4. Now I'm going to add 9 to both sides while simultaneously subtracting 9 cosine squared x from both sides. That's going to give me 9 cosine squared x equals 9 minus 4, which is 5. And then last but not least, we're going to divide both sides by 9. And then now we got cosine nicely isolated. Granted, it's cosine squared, but still. Okay, now since this is something squared, I want to take the square root. So we're going to take the square root of both sides. And cosine of x, therefore, is equal to plus or minus square root of 5 is just square root of 5. Square root of 9 on the bottom simplifies to 3. All right, now we have this. Now the thing is, this is actually not on the unit circle, so we're not going to get explicit values from the unit circle. Nevertheless, we can express exact answers using arc cosine, so let's do that now. So my first two solutions are going to be arc cosine of positive rad 5 over 3, and then arc cosine of negative rad 5 over 3, right? The plus or minus. But now that we have these two values, imagine, where are these going to come back? These are coming back to values in the first quadrant and second quadrant. But again, it's plus or minus. So we should also have values in the third quadrant and fourth quadrant, okay? So if you think about it, the first quadrant, if I add pi to it, now I have that same output value in the third quadrant. So if I also take this value here and I just add pi to it, I got my next value. And same with this one. This is my second quadrant response. Add pi to it, and I get my equivalent fourth quadrant answer or solution. And there you go. There are my 4 solutions. Now, just a quick caveat I want to mention. These are different than the answers in the back of the book. So I believe there's a mistake in the back of the book. These are correct. If you plug them in, you'll see that they evaluate out to be the same answers on both sides. You can even graph it, and you'll see that this is the right solution. So there you go. That's how you do it. Boom, done. For this one, I'm going to start with the double angle identity. And in particular, since I have only sine on the right-hand side, I want to use this double angle identity for cosine of 2x. So I'm going to replace it now. And I know the variable is t, but I'm just using x. I like writing x better. I just feel like it's simpler. So now I've got basically a quadratic, right? I got something to the second power, something to the first power. So I'm going to use the zero product rule. I'm going to set everything equal to 0. So I'm going to add 2 sine squared x to the right-hand side and subtract 1. But when I do that, I'm actually going to write it on the left-hand side. Again, that's just a preference of mine. So it's 2 sine squared x plus sine of x minus 1 equals 0. Now what I'm going to do is I'm going to factor this as if it were 2y squared plus y minus 1 equaling 0, and I'm going to use the star method for this. The first term, or the a term, is going to be 2, that's going to go here. A times c, -2, is going to go up top, and then +1 on the bottom. Then I think of two numbers that multiply to -2, add to +1, that's +2 and -1. Where I place these is arbitrary. And then I reduce, if possible, like a fraction. 2 over 2 is just 1 over 1. So now I know how to factor this, and now instead of y, I'm going to use the sine of x as my y. So for the first one, it's going to be just 1 sine of x plus 1, that's this right here, right? Times 2 sine of x minus 1, that's this right here, okay, equals 0. Now I have two possibilities. I'm trying to figure out when sine of x plus 1 equals 0, aka when does sine of x equal -1, right? When is that going to zero out? And then for this one, when does 2 sine of x minus 1 equal 0, aka if I add 1 and divide by 2 to the other side, when does sine of x equal 1/2? Okay. All right. So now we have this. Now let's go to our unit circle and see if we can find these solutions, because this is all in the unit circle. So sine corresponds with the y values of the coordinates on the unit circle. So I see -1 just in one spot. So that means one of our solutions is 3 pi over 2. And then when does it equal +1/2? And so now that I have that, again, I need to find where the y value is equal to 1/2, and I see it here and I see it here, okay, which means my corresponding solutions for the angles are pi6 and then also 5 pi6, okay? So here are your three solutions done. So for this one, this looks like a quadratic, so I'm going to factor it and see what we can do with that. So first, they both have a tangent of x, so I'm going to factor that out. So I got tangent of x times tangent of x minus rad 3. And this is all set equal to 0. Now, this is great once I factor, because I can make two separate equations. First, I'm trying to figure out when this argument goes to 0. And then I'm trying to figure out when this second argument, tangent of x minus rad 3, goes to 0. Okay, so when does tangent go to 0? Well, if you remember, tangent is y over x when we look at the unit circle. So obviously, we can't divide by 0, but it's going to be when 0 is on the top, aka 0 for a y value. So that is going to occur here and here, which means my two solutions there are going to be 0 and pi radians. Now over here, as I isolate, tangent of x is going to equal positive rad 3. Okay, when is this going to happen? This is going to be when my y value is rad 3 over 2 and my x value is 1/2, because rad 3 over 2 divided by 1/2 is rad 3. But it's also going to occur when they're both negative, because then the negatives will cancel out. So I got two more radian values. I've got pi thirds and I've got 4 pi thirds. So these are the four solutions done. So for this one, we're going to start out by factoring if this is possible, right? Because we've got an x squared basically, then a -2x, and then a -4. But the thing is, this equation is actually not factorable. We know that because there are no two nice numbers that multiply to -4 and then add to -2. As such, we're going to have to use the quadratic formula. But before we do that, I'm going to just replace y sine of x with y. I'm going to say y equals sine of x, and then we're going to say y squared minus 2y minus 4 equals 0. Then I'm going to solve for y using the quadratic formula, and then we're going to apply that back to this original equation. Okay, so the quadratic formula says if this is a, this is b, this is c, and I'm talking about these coefficients. It says that if it's set equal to 0, y equals -b, which is +2, plus or minus the square root of b squared, which is 4, minus 4, times a, which is 1, times c, which is -4. Notice I didn't write the 1 because it doesn't change anything. Over 2a. 2 times a, or 2 times 1, is 2. Now this simplifies to -4 times -4 is 16, plus 4 is 20 over 2. And then I can simplify the square root of 20 because it's really 4 times 5, right? And square root of 4 can be simplified to 2. So this can now be 2 plus or minus square root of 4 is 2. So it becomes 2 rad 5 over 2. Last but not least, divide everything by 2, and I get 1 plus or minus rad 5. Okay, so here's my value for y. So now I'm going to plug that back in up here. And so now I got sine of x equals 1 plus or minus rad 5. Okay, now this is not on the unit circle, so I can't get a nice radians value of like pi 6 or pi 4s, but I can use arc sine to now solve for this. But there's an issue here, okay? And the issue is that 1 plus rad 5 is approximately 3 point something. Well, here's the situation with that. there is no value of x that's going to give me something above 1 or below -1. All my values for sine have to be within that range. The other way to think about it is this is outside of the domain of arc sine. Likewise, 1 minus rad 5 is in a similar situation, okay? Because 1 minus rad 5 is just a little bit beyond -1. It's like -1 point something. Neither of these are going to yield viable responses, which means that this is no solution. Boom, done. For this one, I'm going to start with a little substitution. I'm going to say y equals cosine of x. Then I want to look at this as 3y squared minus 2y minus 2. And I want to see if this is even factorable. Using the star method, I would put a here, which is 3, and then I've got a times c, 3 times -2, which is -6 up here, and then b, -2 down here. So the thing is now, are there two numbers that multiply to this and add to this? And in fact, there are not, which means this is not factorable, hence we must use the quadratic formula to solve for y. So I'm going to solve for y, and then I'm going to plug it back in to solve for actually x here, okay? So the quadratic formula is negative b, which would be -2, which is 2, plus or minus the square root of b squared, which is 4, minus 4 times a times c, that's -2, all over 2 times a, which is 2 times 3, which is 6, okay? Now, as we simplify this, this becomes 2 plus or minus. These negatives are going to cancel out. 4 times 3 times 2 is 24, plus 4 is 28. And then I can simplify square root of 28, because it's really, well, let's not write it so close to that, but it's really 4 times 7. And I can take the square root of 4 as 2, and the 7 stays trapped inside. So then I get 2 plus or minus 2 rad 7 over 6. And then I can divide everything by 3, which gives, or sorry, by 2, which gives me 1 plus or minus rad 7 over 3, okay? So this is nice and simplified. Now we need to sub this back in for y to solve for x. So, and I'm factoring out 1/3 from this only because they did it in the back of the book. Otherwise, it doesn't really matter. You don't need to. But I'll factor out a 1/3, and then I have left 1 plus or minus rad 7 is equal to cosine of x. Now, here's the deal. This whole thing is not on the unit circle, right? So I can't just look at the unit circle and find an equivalent value. But what I can do is I can take arc cosine of both sides. So x equals arc cosine of 1/3 times 1 plus or minus rad 7, okay? But there's a situation here. 1 plus rad 7 is, and then even times 1/3, that's going to be bigger than 1, okay? And if you plug this into a calculator with the plus, it's actually going to, it's not going to give you an output because that's outside of the domain of arc cosine, which means we can eliminate the plus solution. But the minus solution, that's still legit. 1 minus rad 7 is going to be fine when you multiply it by 1/3. That's going to be between -1 and 1. So that's legit. So this is one viable solution. Now, again, this is a negative output, which means this is going to return something in the second quadrant. Let's just say like here. But cosine is also negative in the third quadrant. So we should also have another option in the third quadrant. So the way we can do that is if I take this angle and I subtract it from 2 pi, going all the way around, we end up with a value in the third quadrant that has the same reference angle. So I can take this and I can say 2 pi minus arc cosine of the same value, 1/3 times 1 minus, rad 7, like so. So these are your two answers. That's how you do it. Boom, done. For this one, ideally, we'd factor, but as you might notice, there's no such thing as two numbers that, or whole numbers that multiply to -1 and add to +5. So clearly, we're going to have to use the quadratic formula. So I'm going to start by setting y equal to tangent of x, and then I'm going to rewrite this as y squared plus 5y minus 1 equals 0. And then I'm going to use the quadratic formula a, b, and c here, which is -b plus or minus the square root of b squared, which is 25, minus 4 times a times c, all over 2a, which is just 2. So this becomes -5 plus or minus, and then the negatives cancel out. 25 plus 4 is 29 over 2. Now this is equal to y, so I'm going to sub it back into this equation, which is saying tangent of x, therefore equals my y value, which is -5 plus or minus rad 29 over 2. Okay, so this value clearly does not exist on the unit circle, so we're not going to be able to find it that way. So instead, we're going to have to take arctangent of both sides. So first I'm going to get arctangent. I'm going to factor 1/2 out. Again, this is only because they do it in the back of the book. You don't really need to do it unless your teacher is asking you. But so I have arctangent of 1/2 times positive rad 29. And then, since that 5 is negative, minus 5. Again, this is how they wrote it. You could put negative 5 plus rad 29. And then the other value is going to be arctangent of 1/2. And then for the minus, negative rad 29 minus 5. But the thing about this is that it's going to return something as a negative radians value. So we don't want a negative, right? We want between 0 and 2 pi. But that to get that correct value, all I got to do is I got to add pi to this. Now, there are 2 more solutions that are going to work for this. Again, it's because of that plus or minus. We know it's probably going to be 4 solutions, right? So then I've also got this same answer, but I can add pi to this. It's going to give that same reference angle. And then I'm going to do the same with this second angle. I'm going to add pi to that, which is going to make it 2 pi here. And these are your 4 exact solutions done. For this one, I'm going to start by dividing everything by -1 because I don't want my leading term to be negative. So I'm going to make that tangent squared x plus tangent x plus 2 equals 0. Then I'm going to take the tangent of x and set it equal to y. So we can do a little substitution. And by the way, the first thing you might want to ask is this factorable? But it's not, because there's not 2 numbers that multiply to 2 and add to 1. So this doesn't exist. So we know we're going to have to use the quadratic formula. So I'm going to reformat this as y squared plus y plus 2 equals 0. And then let's plug and chug, but this is a, b, and c. So we got negative b, which is -1, plus or minus the square root of b squared, which is 1 minus 4 times a times c, all over 2 times a, which is 2. Now, I have something interesting in here. I have 1 minus 4 times 1 times 2. That's 1 minus 8, which is -7. But the thing is, we can't take a square root of a negative and get a real solution. So this is already out, which means we have no solutions for this one. That's it, done. So this one we can address pretty quickly because if you remember your Pythagorean identities, sine squared x plus cosine squared x always equals 1, which means that there's no values of x such that this will ever equal 0. It's always equal to 1, so hence no solution, done. So for this one, I'm going to start with the double angle identity, and I'm going to use the middle one because I got a cosine here, so I want to keep it to cosine. So I'm going to sub in 2 cosine squared x minus 1 for cosine of 2x, and then we got minus cosine x. Now I'm going to reorganize it to be 2 cosine squared x minus cosine of x minus 1 equal to 0. Because now I'm going to see if I can factor this. And again, imagine this as 2y squared minus y minus 1 equal to 0, right? Where I'm subbing in y for cosine of x. Now we're going to see if we can factor this using the star method, where this is a, b, and c as those coefficients. So a goes here, a times c, -2 goes up here, right? 2 times -1. And then -1 goes down here. And then we ask the question, what 2 numbers multiply to -2 and add to -1? That would be -2 and +1. And then I reduce this one like a fraction to become 1 over -1. Okay, so this is how you factor it. Now, I'm going to straight go back to the cosine of x. I'm going to factor it as such, right? So the 1 goes with the variable. It would be 1y, but like I said, I'm plugging cosine back in. So 1 cosine of x minus 1, that's the bottom value. And then this one is 2 cosine of x plus 1. And all of this is set equal to 0. Sorry, I just made some room. So now I have 2 nice equations. I have cosine of x minus 1. When does that go to 0? And then I also need to figure out, when does 2 cosine of x plus 1 go to 0? All right, let's isolate. So I'm going to add 1 to both sides. When does cosine of x equal 1? And then as I subtract 1 and divide by 2, I'm going to do that in one step. When does cosine of x equal to -1/2? Now we're going to use the unit circle, because cosine is really saying when is the y value going to equal this or this on the unit circle. So I see +1 occurring in one spot when the radians are 0. So one possible answer is 0 radians. And then for -1/2 on the x values, I see 2 spots here and here, which means my other 2 answers are 2 pi thirds and 4 pi thirds. So we got 2 pi thirds, 4 pi thirds, and those are your 3 solutions. Done. So for this one, I'm going to start by subtracting 1 from both sides. Now I have negative cosine of 2x equal to cosine of 2x. Now what I'm going to do to solve this is I'm actually going to use a double angle identity. And I'm going to use this one, 2 cosine squared x minus 1. So what I've done is I've replaced each of these with 2 cosine squared x minus 1. This is a bit of an arbitrary decision in terms of which one to use, but I'm going with this one. I think it's going to work out nicely. Now I'm going to distribute the negative, and then I have negative 2 cosine squared x plus 1 equal to positive 2 cosine squared x minus 1. Then I'm going to subtract this from both sides, and then I'm also going to subtract this from both sides simultaneously. So it's going to destroy that and that. And then I have negative 4 cosine squared x equal to negative 2. Divide both sides by negative 4, and then I have cosine squared x equals to negative 2 over negative 4, or 1/2. Then I'm going to take the square root of both sides, and we get cosine of x equals square root of 1 is 1, square root of 2 is square root of 2. So I get 1 over rad 2, and then to rationalize, and this will be nice for the unit circle, I get rad 2 over 2. But don't forget, this is plus or minus because it's a radical. So any place where I have positive or negative rad 2 over 2 as an x input will be a viable solution. So this is occurring here, 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 and here. Hence, the corresponding solutions are pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. And those are your solutions. Boom, done. So for this one, I'm going to start by subtracting 6 cosine x from both sides. And then we got this nice thing set equal to 0. Then I'm going to factor out cosine of x. And let's factor out a 2 as well. And then inside I have 5 sine of x. And then if you factor 2 out from that and a cosine of x, it's going to be minus 3, like so. So now I got 2 solutions, right? Or 2 equations I can make. I got when this part equals 0 and when this part equals 0. So for 2 cosine x equaling 0, divide by 2, when does cosine of x equal 0? AKA, when is the x value going to be 0? I see it here and here. So those 2 solutions for x are pi halves and 3 pi halves. And then for my other equation, it would be when does 5 sine of x minus 3 equal to 0. So to solve this, first I'm going to isolate. I'm going to add 3 to both sides like so. And then I'm going to divide by 5. So sine of x equals 3/5. Now this is not on the unit circle, so I'm going to have to take arc sine of 3/5. Now this is going to give me an output in that first quadrant, but I'm also going to have a viable answer right in the second quadrant because it's going to have the same reference angle and sine, which corresponds to the y values in the unit circle. That's also going to be positive in quadrant 2. So how do I get that same reference angle in quadrant 2? I take this value and I just subtract it from pi. So there we go. There are 4 solutions. That's how you do it. Done. For this one, I'm going to start by subtracting 15 cosine x from both sides. Now, just to make it easier in terms of factoring, I'm actually going to replace cosine of x with y. And then to see if this factors, I'm going to apply the star method such that I put my a values here, the 4, a times c, which is 4 times negative 4 is negative 16, and then b down here. And then we're going to see if any 2 numbers that we can think of multiply to negative 16 and add to negative 15. That works because we can do negative 16 and positive 1. Those add to negative 15, multiply to negative 16. Now reduce this side like a fraction, divide by 4 and 4, so I get 1 and negative 4. So this is now how it factors. And I'm going to also, when I factor it, I'm going to plug the cosine of x back in. So I've got 1 cosine of x minus 4 times 4 cosine of x plus 1, and all of this equal to 0. This gives me 2 equations. 1 cosine of x minus 4 equal to 0, and the second one, 4 cosine of x plus 1 equal to 0. Now this is going to give me an issue because when I add 4 to both sides, I get cosine of x equals 4. Now, cosine can't return values greater than 1 or less than negative 1, which means this is a no solution situation. For this one, however, we will get a solution, so I'm going to subtract 1 by both sides and then divide by 4. So the question is, when does cosine of x equal negative 1/4? Okay, to get that answer, we're going to have to take arc cosine. And by the way, this value is not on the unit circle, so I can't just look at the unit circle and get my solution. So x is going to equal arc cosine of negative 1/4. Now, this is going to return a value in the second quadrant because that's when cosine is negative. So we're talking about a value there, but we should also have a value in the third quadrant because cosine is also negative in the third, right? Because that cosine links to the x values. So what is that same reference angle, right? that we have here in the second quadrant that would exist in the third quadrant. And we can find that just by subtracting this angle from 2 pi. So the second answer would be 2 pi minus this exact same angle. So these are your two solutions. Done. So for this one, we're going to start by using the zero product rule by setting everything equal to 0 because I have that nice quadratic, right? Something squared, something not squared to the first power, and then a constant. So we have 8 cosine squared, and I'm going to say x instead of theta, just using a different variable because it's easier to write. And then I'm going to add 2 cosine theta, or cosine x in this case, to the left side, and also going to subtract 3, and now we got this equal to 0. Now I'm going to replace cosine of x with y of x, and we're going to see if I say 8y squared plus 2y minus 3, we're going to see if this is factorable. So using the star method, I'm going to place a, b, and c here. So a goes here, a times c, negative 24 goes up here, and then positive 2 goes down here. Then the question is, are there any two numbers that multiply to this and add to this? And actually there are, which means this is factorable. And those numbers are 6 and negative 4. Now I reduce like a fraction. That's 2 and negative 1. Boom. That is, both of those are divided by 2, and we get 4 and 3, boom. And then now as we factor, I'm going to replace the cosine x back in for y. So it would be 4y plus 3. Now it's going to be 4 cosine x plus 3. Top goes with cosine, bottom number is the standalone constant. And then we have 2 cosine x minus 1. All right, now I have two situations. I have two different things that are equal to 0, right? I'm trying to figure out when this is equal to 0 and when this is equal to 0. So first I got 4 cosine x plus 3. When is this equal to 0? And when is 2 cosine x minus 1 equal to 0? All right, let's solve them each now. So we're going to subtract by 3 and divide by 4. I'm going to do that in one step. So we're trying to figure out when does cosine of x equal negative 3/4. And then for this one, I'm going to add 1 divided by 2. When does cosine of x equal positive 1/2? So the good news about 1/2 is that it's on the unit circle. So what we're trying to find on the unit circle is x coordinates, x values for the coordinates that equal 1/2. And I see it occurring here and here. So positive 1/2 in the first and fourth quadrant. And that corresponds with pi thirds and 5 pi thirds. So those are two solutions, pi thirds and 5 pi thirds. And then what about when cosine of x equals negative 3/4, okay? Well, that is not gonna appear on the unit circle, right? Negative 3/4 does not occur in any of the x or y coordinates. So what we're gonna have to do to get the exact values, take arc cosine of both sides. So x therefore equals arc cosine of negative 3/4, all right? Now the thing is, this is gonna return a value in the second quadrant. That is the range of arc cosine. But if we have a value in the second quadrant, we should also have a value in the third quadrant. Those are the places where cosine is negative. So we're gonna have an answer in each, and then the way to get something in the second quadrant to get an equivalent reference angle in the third quadrant, we just subtract this angle by 2 pi, or, you know, basically 360 if it were in degrees. Like, think about it. Think if we had 150. If I subtracted 150 from 360, I'd get 210. And you can see that they share the same reference angle. Likewise, if I had a 120, you subtract that from 360, you get 240. And there's a reason why they're both colored in green on my little infographic, right? Same reference angle. All right. So then we have our last answer is then 2 pi minus arc cosine of negative 3/4. That's how you do it. Boom, done. For this one, we want everything either in terms of sine or cosine because we have a mix, right? We have cosine, we have sine. So what I'm going to do is I'm going to use our famous Pythagorean identity, sine squared x plus cosine squared x. And I know it's t, I'm just going to use x because I like it better. Sine squared x plus cosine squared x equals 1. This is relevant because if I subtract both sides by cosine squared x, I get 1 minus cosine squared x. And this is great because I can substitute that in for this guy. So let's rewrite that. So I have 12 times 1 minus cosine squared, again, substituting in for sine squared, plus cosine of x minus 6 equals 0. Now let's distribute. So then I have negative 12 cosine squared x. I still have a cosine x. And then 12 times 1 is 12, plus that negative 6 gives us a 6. The last thing I'm going to do is I'm going to multiply everything by negative 1. So that's going to turn that to positive, that to negative, and that to negative, okay? And now we're going to see if this is factorable. So I'm going to rewrite this by setting cosine of x equal to y. So now I have 12y squared minus y minus 6 equals 0. Then I'm going to use the star method. We're going to see if this is factorable. So this will be a, b, and c. A goes here, B goes down here is -1, right? I'm talking about the coefficient. And then A times C, 12 times -6, -72 goes up top. Now, are there two numbers such that when they multiply, you get -72, add, they get -1? Yes. We have -9 and +8. Now I'm going to reduce these like fractions. 12 over 9 reduces to 4 over 3. And don't forget the negative still stays there. And then 12 over 8 reduces to 3 over 2. All right. So that's how we factor it. So now I'm going to write it in factored form. And simultaneously, we'll replace the y again back with cosine of x just to save a step. So then I got 4 cosine x minus 3, right? Top goes with cosine, bottom is a standalone constant. And then over here, 3 cosine x plus 2, same situation, top with cosine, bottom as standalone. All right, now we can solve for this because I can set this equal to 0 and this equal to 0 separately. So what this really means is 4 cosine x minus 3 equals to 0 and 3 cosine x plus 2 equal to 0. Now let's solve them and make room by moving this because the values we're going to get are not going to be on the unit circle. So anyways, we add 3 divided by 4. When does cosine of x equal +3/4? And then subtract 2 divided by 3. When does cosine of x equal -2/3? So to solve this, I'm going to take arc cosine of 3/4. So x equals arc cosine of 3 over 4. But that's an answer in quadrant 1. That's where cosine is positive, of course, but cosine is also positive in quadrant 4. So we also need another angle with the same reference angle in quadrant 4 that will also give the same value. And that will be, right, let's say this is a certain value, just pretend that was like 30, then the other angle with the same reference angle in quadrant 4 would be 330, hence 360 minus this angle. So we're doing a similar type of thing here. Obviously we're in radians, so instead of 360, we're using 2 pi. But basically I'm taking this first quadrant angle and I'm subtracting it from 2 pi. All right, cool. So those are my first two answers. Then what about this? The answer here is arc cosine of -2/3. Now, cosine is negative in the second quadrant. So arc cosine of a negative is going to return something in the second quadrant. To get the same reference angle in the third quadrant, because cosine is also negative in the third quadrant, we've got to subtract our angle in quadrant 2 from 2 pi, just like we did here. So it's going to be 2 pi minus arc cosine of -2/3. Boom. So those are your 4 answers. Boom, done. So for this one, what I'm going to do is I'm going to start by setting everything equal to 0. So I'm going to say cosine cubed, and I'm just going to rewrite t with x. I know it's t, but we're just going to say x. I like writing it better. Minus cosine x equals 0. Okay, now I can factor out a cosine, right? And then I have cosine squared x minus 1. Okay, now this is going to give me the basis for 2 different equations. One is just when this equals 0, and one when this piece equals 0. Now, when does cosine of x equal 0? Well, on the unit circle, we're looking for x values because cosine links up with x. We're looking for x values in the coordinates that are equal to 0. So I see it happening here and here. So it corresponds to these two radian values so that we've got pi halves and 3 pi halves. These are our first two solutions. And what about this? Well, I'm going to add 1 to both sides. We got cosine squared x equals 1. Take the square root of both sides. Cosine of x equals plus or minus 1. Okay, so now we're trying to look for x values that are either 1 or -1. So where does that exist? It occurs here and here, which means we get 2 more values, 0 and pi. So we get pi halves, 3 pi halves, 0 and pi. Those are your 4 solutions. Done. So for this one, we're going to start by replacing cosine of x with y. It's going to make it a little bit easier to see if this is factorable. So I got 8y squared minus 2y minus 1 equals 0. Now let's use the star method to see where I've got a, b, and c. So a is 8, a times c is -8 up top, and then b, -2 is down here. So what two numbers, if they exist, multiply to -8, add to -2? They do exist. It's -4 and +2. Now I'm going to reduce like fractions. 8 over 2 becomes 4 over 1. 8 over -4 becomes 2 over -1. All right. So now we have this, and then we can put it in factored form. I'm going to go back to our to cosine of x, not y. So I'm going to say 2 cosine of x. I could say 2y minus 1, but why not save a step? 2 cosine of x minus 1. And then here we got 4 cosine of x plus 1. Okay, so when is this going to equal 0 and when is this going to equal 0? So for the first one, I got 2 cosine of x minus 1 equal to 0. And for the second one, I got 4 cosine of x plus 1 equal to 0. So I'm going to add 1, divide by 2. When does cosine of x equal 1/2? So this is actually on the unit circle. So I want to look for x values on the unit circle and those corresponding radian values. So I see positive 1/2 occurring here, and I see it occurring here. So that means my two solutions are pi thirds and 5 pi thirds. All right, cool. Now for this one, I'm going to subtract 1 divided by 4. So then I got cosine of x equals negative 1/4. This value does not appear in the unit circle, which means I have to take arc cosine of negative 1/4. So this yields a value because it's negative in the second quadrant, okay? That's the range of arc cosine, first and second quadrant. If it's negative, it's got to be second quadrant. But there's also going to be another value with the same reference angle in the third quadrant, and we can get that by taking our second quadrant angle and subtracting it from 2 pi. So 2 pi minus arc cosine of negative 1/4. So boom, those are your 4 answers, done. For this one, I'm going to start by replacing cosine with y. So we're going to say 2y squared minus y plus 15, right? Where y equals cosine of x. So my first order of business, I want to see if this is factorable. So we're going to try via the star method, where I've got a, b, and c. So a goes here, 2 and 2. Again, we're talking about just the coefficients. B, which is negative 1, goes down here. And then a times c, 2 times 15, which is 30, goes up here. And then the question is, are there any two numbers such that they multiply to positive 30 and add to negative 1? Now, this is a situation where there are no such numbers, okay? Because we're going to need two negatives to multiply to a positive and add to negative, but there's nothing that's going to multiply to 30 and add to negative 1. So this is not going to be factorable. So our only option is to use the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. So we got a, b, and c. Let's do it. So negative b, which is 1, plus or minus the square root of b squared, which is 1, minus 4 times a times c all over 2a, which is 2 times 2, which is 4. Now, before we go any further, notice what we have in here. 4 times 2 is 8 times 15 is 120. 1 minus 120 is negative 119. That means this would require us to take the square root of a negative, which is not a real solution, which means that we're done. We don't have to go any further. There is no solution, no real solution, I should say. No real solution for this, so that's the answer. Boom, done. For this one, I'm going to start by replacing tangent with y by substitution. And then we got 2y squared plus 7y plus 6 equal to 0. Now we're going to see if this is factorable using the star method, a, b, and c. I'm going to put a here and here. A times c, which is 2 times 6, which is 12 here, and 7 down here. Now the question is, are there two numbers that multiply to this and add to this? And there are. 3 and 4. Now I'm going to reduce like a fraction, and we got 1 over 2, not 2 over 1, 1 over 2. And those are the coefficients for the factoring. So now I'm going to factor it like so, and I'm going to just swap the tangent of x back in for y. So I'm not going to keep the y. So instead, I'm going to say 2 tangent x. The top number goes with the variable, bottom number is the standalone constant, plus 3. Same with this. 1 tangent of x plus 2 equals 0. Now I've got two separate equations. First, I got 2 tangent x plus 3 equal to 0, and tangent of x plus 2 equal to 0. So I'm going to subtract 3 divided by 2. Tangent of x equals negative 3/2, and subtract 2. Tangent of x equals negative 2. Now the thing is, on the unit circle, tangent is really the y values over the x values, but there's going to be no such combination from the unit circle that's going to give me either negative 3/2 or negative 2. So we're going to have to take arctangent of both sides. So for this one, we're going to have arctangent of negative 3/2, and this one we're going to have arctangent of negative 2. Now the range for arctangent is from negative pi halves all the way up to pi halves. It's the same as sine, okay? So what that means is when I'm taking arctangent and I'm getting of negative values, my outputs can either be in quadrant 1 or quadrant 4. And so since I'm taking negatives, these are going to give me values in quadrant 4. Also, they're going to be negative angles, which is outside of our 0 to 2 pi area, right? So let's have an angle in here. If I want it to have the coterminal angle that's positive, all I got to do is add 2 pi. So for these two, I have to add 2 pi to them to put them in the 0 to 2 pi range. So now these are fourth quadrant angles, right? So I need to get the equivalent now in the second quadrant because tangent is negative in the fourth and second quadrant. So if we take a second quadrant angle to get that equivalent angle, meaning with the same reference angle, I got to subtract by pi. So basically, I take this and I subtract pi, which means the other angle is just 1 pi arctangent of -2, and same with this one, 1 pi plus arctangent, whoops, like this, of -3/2. So these are your 4 solutions, done. So for this one, it says to use a calculator. So to start to solve this, what I'm going to do is I'm going to take arcsine of both sides. So now I got arcsine of 0.27. All right. Now, if we think about our unit circle, and again, this value is of course not on the unit circle, but if I'm taking arcsine of a positive value, I'm going to return an angle in the first quadrant. But sine is also positive in the second quadrant. So we also need another angle in the second quadrant that is the same reference angle as this first angle in the first quadrant. So the way we can get that is by taking an angle in the first quadrant and subtracting it by pi. So my 2 solutions are going to be this and this, okay, where it's pi minus arcsine of 0.27. Let's plug it into the calculator and see what we get. So our 2 solutions are 0.2734 and 2.8682, okay? But there's one other thing. So as we write these down, there's one other thing to remember. They said all solutions. So this is just 2 between 0 and 2 pi. So let me show you how we get every single possible solution. So here are the 2 solutions that we found between 0 and 2 pi. But if you remember coterminal angles, because again, look, we're solving for x, that's an angle in radians. So all coterminal angles to infinity are going to be viable solutions. So what's coterminal to this? If I add 2 pi, or if I add 2 pi again, or again, or again, or subtract by 2 pi, etc. So as long as I add by multiples of 2 pi such that, you know, k is any integer, this is going to give every possible solution. I just do the same with this one. Add all possible variations, all coterminal angles. So these are your solutions, done. So for this one, we're going to start by taking arctangent of both sides. So we got arctangent of -0.34. Now, if you think about arctangent and the range, it goes from -pi/2 to pi/2. So we're either outputting values in the first quadrant or the fourth quadrant. Now, we have a negative input for arctangent. We're giving something in the fourth quadrant, but this is going to give me also a negative value for tangent. So there's going to be another angle there. So let's just think about that. Plus, by the way, not to mention, we want all solutions, not just between 0 and 2 pi. So anyways, let's go back and let's go to Desmos and see what this gives us. So here we get -0.3277. So I said we also want this angle, right? And look at this. We can just add pi to that. And the other beauty of this is that the period of tangent is just pi. It's not 2 pi like sine and cosine. So that makes it easier because once we get a single value that works, basically we just add on pi to this and different multiples of pi, hence k is an integer, any integer. And we got our solutions. We got every solution. So that's how you do it. Boom, done. So for this one, I'm going to start by setting tangent of x equal to y, and then I'm going to do a little substitution. Then if this is factorable, it will only be if you can get 2 numbers that multiply -3 and add to +3, but that doesn't exist. So instead, we're going to have to use the quadratic formula. So -b plus or minus the square root of b squared, 3 squared, which is 9, minus 4 times a, which is 1, times c, which is -3. All over 2 times a, 2 times 1 is 2. All right, so what is this? This is -3 plus or minus, the negatives cancel out, so it's 9 plus 12, which is rad 21 over 2. Okay, this is great, because now tangent of x equals -3 plus or minus rad 21 over 2. Okay, so just in simple terms, right, what I'm going to have to do is I'm going to take arctangent of both sides, because this obviously isn't on the unit circle. So my 2 solutions as of now are arctangent of -3 minus rad 21 over 2 and arctangent of -3 plus rad 21 over 2. Now, before we do anything else, I'm going to plug these in. I want to see what values we get. Now, here are my two initial values, but the problem with this one up here is it's less than 0. So we don't want that. We want to find a coterminal angle with this angle in radians. So I'm going to add 2 pi to it. That's how I find coterminal angles, right? Now I got a legit value. I got 4.97 whatever, and this one 0.6694. So these two are great because these are my starting points. And then because the period of tangent is pi, I'm going to have something with this one, and I can either add or subtract pi. Well, of course, I can't add pi. That'll go beyond 2 pi, which is 6.28 approximately. I'm going to have to subtract pi for this one. So there's our third angle. And for this one, I'm going to add pi to it and see what we get here, because that will be our fourth angle, our fourth answer. Add pi, again, because the period is pi. And so here are our 4 solutions. So I just copied and pasted them here. Now let's round to 4 decimal places. So the first one is 4.9703. The second one is 0.6694. The third one would be 1.8287. I believe, wait, 87. And then the last one is 3.8110, because that's going to round up to 0, and that's going to bump it up to 1. So here are your 4 final solutions. You notice everything's between 0 and 2 pi, aka between 0 and roughly 6.28. That's how you do it. Done. So for this one, we've got tangent squared and secant, right? We got 2 different trig functions. That's usually not a good thing. So we want to convert one to the other. And nice enough, we've got this beautiful identity here, right? Tangent squared x plus 1 equals secant squared, which means that if I subtract 1 from both sides, I can say tangent squared x equals secant squared x minus 1. So now I can plug this in for tangent squared. So now I got secant squared x minus 1 minus secant x equal to 1. So now I'm going to set everything equal to 0 by subtracting 1 from both sides, and I got secant squared x. I'm going to just move this to the middle term, minus secant x, and then -1 minus 1 is -2 equals 0. Then I'm going to set secant x equal to y, and I'm going to see if this is factorable, right? So I got y squared minus 1y minus 2 equals 0. And this is factorable, right? Because I can think of 2 numbers that multiply to -2, add to -1. That would literally be -2 and 1, right? You add those, they get -1, multiply, you get -2. And then I'm going to put in here the y's, or I can substitute this back in just to save a little time. So I'm going to say secant of x minus 2, secant of x plus 1. Now I've got 2 equations that I can make. The first one is secant of x minus 2 equals 0. The other one is secant of x plus 1 equal to 0. So then I got secant x equal to -1. And here we got secant x equal to, by adding 2 to both sides, equal to 2. All right. Now what we can do is we can actually take arc secant of both sides to get our answers. But if your calculator doesn't have an arc secant function, you can also remember that secant is the same as 1 over cosine of x, right? Equals to 2. And this one would be 1 over cosine of x equals to -1. So then you can see you can cross multiply and do your whole thing, and you'll still make it work. But anyways, let's go to Desmos. So here are 2 answers for now. So let's bring these back over. So far we have 1.0472. We also have 3.1416. Okay, so now we've got these 2 values, and these are great. But now the question is, are there more values? Now, if you remember in the unit circle, and by the way, this might look familiar, that's pi. That value that's going to give us our -1, right? That is right here on the x-axis. There's not going to be another angle from 0 to 2 pi that's going to have the same reference angle. This is it. This is your one and only. But this one, this is in the first quadrant. And if you remember, secant, similar to cosine, is positive in the first and fourth quadrants. So the way we're going to get a second angle like this one that's going to have the same reference angle, okay, is we're going to take this angle, which is in the first quadrant, and we're going to subtract it from 2 pi to give us this angle. Okay, so we're going to do that in Desmos. And we get this 5.2360. So our last angle is 5.2360. Those are the 3 answers. Boom, done. For this one, I'm going to start by replacing tangent of x with y with a little substitution. So y is equal to tangent of x. So then I got 2y squared plus 9y minus 6 equal to 0. Then I want to see if this is factorable via the star method, where this is a, b, and c. So I got a up here, a times c, 2 times negative 6, which is negative 12 here, and then 9 here. So are there any two numbers that multiply to negative 12 and add to 9? No, there's no such combination. Therefore, this is not going to be factorable, and we're going to have to use the quadratic formula, which is negative b plus or minus the square root of b squared, that's 81, minus 4 times a, right? There's a, times c is negative 6, all over 2a. 2 times a is 4 in this case. Let's simplify. We got y equals negative 9 plus or minus negative 4 times 2 is negative 8 times negative 6 is positive 48. 48 plus 81 is 129. So we got 129 and all over 4. All right. And if we now remember, y is the same as tangent of x. So now to get our solutions, we have to take arctangent of both plus and minus, right? So it's x equals arctangent of this whole crazy thing, and then we're going to plug this into decimals. Negative 9 plus or minus square root of 129 over 4. So let's do that now. So right off the bat, I get a positive value, which is between 0 and 2 pi. That's great. But this one is giving me something that's obviously less than 0. So the first thing I'm going to do with this is I'm going to find a coterminal angle by adding 2 pi. And now we got two viable solutions. And guess what? Tangent, there's a period of pi, which means that if I take each of these answers and either add or subtract pi, I'm going to get another viable solution. And remembering that I want it between 0 and 2 pi, aka between 0 and 6.28, this one I can definitely add pi. So I'm going to take this and I'm going to add pi, and we get a third answer. But this one, it's too big, right? If I add pi to this, if I had, 3.14, whatever, it's going to be greater than 6.28. So that means I have to minus 1 pi from this. And now we have our 4 answers. So I'm just going to paste them here. Now I'm going to round them all to the 4 decimal places. So we got 0.532, what is that, 6? And then I got 4.9064. I've got 3.6742. And last but not least, I have 1.7648. And those are my 4 solutions. Boom, done. So for this one, I'm going to start by setting y equal to cosecant x, and then we're going to see if this is factorable. So the question is, are there two numbers that multiply to negative 4 and add to negative 3? Yes, it'd be negative 4 and 1. So then I can factor this. I'm going to sub cosecant back in for y. So I got cosecant x here, and I got minus 4 plus 1. All right, so this is going to give me two possible scenarios, when this equals 0 and when this equals 0. So then I'm going to add 4 here, cosecant of x equals 4, and here cosecant of x equals negative 1. Now, here's the thing. This one is not going to appear on the unit circle, so we can take the answer by taking arc cosecant of 4. But in the back of the book, they didn't use cosecant, they used arc sine. And that's not too difficult to do, because if we remember, cosecant is the same as 1 over sine of x. By the way, you don't need to do this. You could take arc cosecant of both sides, but let's just do it the way they did it in the book. So now I have 1 over sine of x equals 4. Then if I divide by 4 by multiplying by sine of x, I got sine of x now equals 1/4. Okay, cool. Now, we don't have a 1/4 appearing on the unit circle, so to get this value, we have to take arc sine of 1/4. So let's do that up here. Arc sine of 1/4 is one of the answers. Now, if you remember arc sine, the range is from negative pi halves to pi halves in the unit circle. And so since this is a positive value, I'm outputting in quadrant 1. But the thing is, because sine corresponds with y values, sine is positive in quadrant 1, but it's also positive in quadrant 2. So to get another angle that has an equivalent reference angle in quadrant 2, I just take this value and I subtract it from pi. So I've got arc sine of 1/4 and also pi minus arc sine of 1/4. All right. And then we have this cosecant of x equals negative 1. This actually does appear on the unit circle, because here's the thing. Cosecant is going to be negative 1 at the same point when sine is equal to negative 1, because cosecant is the reciprocal of sine. The reciprocal of negative 1 is negative 1. So I may as well just call this, when does sine of x equal negative 1? AKA when is the y value -1? At this point right here. And what is that angle measure if you remember on the unit circle? That's at, this is 90, 180, and 270 degrees. But in radians, that's 3 pi over 2. Hence, we have our 3 solutions. Boom, done. So for this one, I see a commonality here and here. And I can factor this out of both of these different expressions. So I can say 1 minus sine squared x, and then times what remains inside, sine squared x plus cosine squared x. Okay, now this is great because sine squared plus cosine squared, that's a Pythagorean identity. That equals 1, so that's gone, and that's just 1. Now I have 1 minus sine squared equals 0. But from another Pythagorean identity, since sine squared plus cosine squared equals 1, if I subtract, right, and try and get 1 minus sine squared x, that equals cosine squared x. So to make this even simpler, just turn that into cosine squared x. So cosine squared x times 1 is just cosine squared x. So the question is, when does cosine squared x equal 0? So first I'm going to take the square root of both sides. Square root of 0 is 0. So when does cosine of x equal 0? So if we think about our unit circle, cosine corresponds to the x values. So when do the x values on the unit circle equal 0? Here and here on the y-axis. And what are these angle measures? Here we have 0. Here we have pi halves, here we have pi, and here we have 3 pi over 2. So it's going to be at this point and this point, which means my two solutions are pi halves and 3 pi halves. That's how you do it. Done. So for this one, I'm going to start with the double angle identity because I see cosine of 2x, and I'm going to use this one at the top, where cosine of 2x equals cosine squared x minus sine squared x. So I'm replacing cosine of 2x with cosine squared x minus sine squared x. Now I'm going to distribute, and now I got some like terms that I can combine. These guys combine to give us negative sine squared x, and these guys combine to give us positive cosine squared x. And then we still have a minus 1 over here equal to 1. Now, if you remember back to our Pythagorean identity, which is sine squared x plus cosine squared x is equal to 1, I know that sine squared x, if I subtract cosine squared from both sides, is equal to 1 minus cosine squared x. So that's pretty cool because if I subtract this from both sides, look at that. I get 1 minus cosine squared x, which is the same as sine squared x. So now I get everything in terms of sine squared x. I got negative sine squared x minus 1 equals sine squared x. Now if I add this to the other side, I got negative 1 equals 2 sine squared x. Now if I divide both sides by 2, I get sine squared x equal to negative 1/2. Now here's where we run into an issue. To go to the next stage, I have to take the square root of both sides, right, to solve for sine of x. So the problem is I'm taking the square root of a negative. That's not going to return a real number. That's going to return an imaginary number, which means this is a no solution situation. That's how you do it. Done. So for this one, I'm going to start with two things. One, secant is the reciprocal of cosine, meaning 1 over secant is the same as cosine. So since I got secant squared in the denominator, that's just the same as if I pop cosine squared x back up to the numerator. So first I got cosine squared x times sine of 2x equal to 0. Then I want to use a double angle identity because sine of 2x equals this. So I'm going to plug and chug. So then I got 2 sine x cosine x, like so, all equal to 0. And then I can kind of move this around and combine these guys because they're all multiplying. So then I got 2 sine x cosine cubed x equal to 0. So what am I really saying here? We're really saying this is going to work whenever sine of x equals 0 and also when cosine cubed x equals 0. The 2 doesn't really matter because we can divide both sides by 2 and it basically goes away. Now to continue solving, when is sine of x equal to 0? So if you remember on the unit circle, right, sine corresponds to the y values. So we're talking about zeros occurring here and occurring here. And these radian values are going to occur at 0, right? And also pi. Now for this one, if I take the cube root of both sides, really what we're talking about is when does cosine of x equal 0? And cosine corresponds to x values on the unit circle. That's going to occur here and here. That's when the x values are going to be 0. This is going to be occurring at pi halves and 3 pi halves. So my other two solutions are pi halves and 3 pi halves. So these are your solutions. Done. So for this one, I got cosine and then I got sine, right? So I don't like the fact that I have different functions. So what I want to do is I want to see if I can convert this sine squared to cosine squared. And I can do that using my nice Pythagorean identity, which says that sine squared plus cosine squared x equals 1. So if I subtract cosine squared from both sides, I get sine squared x equals 1 minus cosine squared x. So I'm going to take this and I'm going to plug it in for sine squared x here. So here I replaced sine squared with 1 minus cosine squared x, and then I just got my minus cosine x minus 5 equal to 0. Now I'm going to distribute the negative, and then I got 2 cosine squared x minus 1 plus cosine squared x minus cosine of x minus 5. Now I'll combine like terms here, and then we've got 2 cosine squared x, and then I've got 3 cosine squared x, and then I've got minus cosine x, and then minus 6 equal to 0. Now, what I'd like to do to make this a little easier is I want to set y equal to cosine of x. And then I've got 3y minus 6. Oh, that's supposed to be squared, sorry, equals 0. And then I'm going to use the star method to see if this is factorable, where this is a, b, and c. So a is 3, and then a times c, 3 times negative 6, which is negative 18, goes up top, and then b, which is negative 1, goes on the bottom. And the question is, are there two numbers that multiply to negative 18 and add to negative 1? And the answer is no, so this is not factorable. But what we can do to solve this is use the quadratic formula. So I can say y equals negative b, which is 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a times c, which is negative 6, all over 2a. 2 times 3 is 6. Okay, let's simplify this. The negatives are going to cancel out. 4 times 3 is 12, times 6 is 72, plus 1 is 73. So then I've got y equal to 1 plus or minus the square root of 73 over 6. Now we have to remember that y is the same as cosine of x. So up here, I'm going to rewrite cosine of x equals 1 plus or minus rad 73 over 6. So what I'm then going to do to take the solution for x is I'm going to take arc cosine of both sides, okay? Take arc cosine of 1 plus or minus rad 73 over 6. Now, here's the situation. Arc cosine cannot take values this big or this small if it's minus, right? The domain of arc cosine is from negative 1 to 1. And square root of 73, it's between 8 and 9. But, you know, either way, if I'm doing 1 plus 8, right, which is like 9 over 6 approximately, that's bigger than 1. If I do 1 minus 8, that's like, let's say, negative 7 over 6, that's less than negative 1. Both of those values are outside the domain of arc cosine, which means this is a no solution situation. Boom, done. An airplane has only enough gas to fly to a city 200 miles northeast of its current location. And north, we'd say go up. East, we say go to the right. And this is just the normal convention of how we look at things on a map. If the pilot knows that the city is 25 miles north, how many degrees east should the plane fly? So if I look at this as a triangle, right, where I kind of connect the dots here, and I'm saying, all right, I'm flying 25 miles north. I know that this distance is 200 miles. I know it's making a little right triangle. I'm trying to find this little angle. How many degrees north of east should the plane fly? Actually, now that I think about it, really what they're saying is north of east would actually be this little angle here. But the good thing is if I find this angle inside the triangle, the theta that we're trying to find is the complement of this angle. Okay, so how can we do that? Well, let's think about SOHCAHTOA first and recognize like what trig function can we take of x that can utilize 25 and 200, aka adjacent and hypotenuse. Well, adjacent and hypotenuse, that's cosine. So I can say cosine of x is equal to adjacent over hypotenuse, right? So then to solve for this, I can take arc cosine of both sides, arc cosine of 25 over 200. Now, that's going to return this value. And again, to get the complement, aka the theta value that we want, I'm going to subtract this from 90 because the definition of complementary angles is they add to 90. So I'm going to say 90 minus arc cosine of 25 over 200. And again, this is supposed to be in degrees. That's why I'm putting this as degrees, 90, instead of pi halves, which would be the equivalent value in radians. So let's do that now in Desmos. Now, before we calculate this, make sure that you're in degrees mode. If you're in radians mode, it won't give you the right value. So here we get 7.18, which rounds to 7.2. So our answer is 7.2 degrees to the nearest tenth of a degree. Done. If a loading ramp is placed next to a truck at a height of 2 feet and the ramp is 20 feet long, what angle does the ramp make with the ground? So here's our little diagram of the ramp. We got a right angle here. Of course, it's a nice right triangle. We got a height of 2 feet and the ramp is 20 feet long. And it says, what angle does the ramp make with the ground? That's this angle. So again, how do we solve for that? We think back about SOHCAHTOA. And I want to think like, what function can I use with this angle and this side, which is opposite, and this side, which is the hypotenuse. And opposite and hypotenuse is this part, opposite hypotenuse, that's sine. So I can say sine of theta equals opposite over hypotenuse. Now to solve this, I can take arc sine of both sides, like so, 2 over 20. And this will give us our value, so let's do that in Desmos. And here we get approximately 5.7 degrees to the nearest tenth. So 5.7 degrees, boom, done. An astronaut is in a launch rocket currently 15 miles in altitude. If a man is standing 2 miles from the launch pad, at what angle is the astronaut looking down at him from horizontal? So here's our launch pad. We can say here's the man standing and here's the astronaut. And now this is, of course, a nice little right triangle. So what they're asking is what angle is the astronaut looking down at the man? And they're talking about an angle of depression. So to calculate this, we extend out an imaginary line like this. And the angle of depression is this angle, okay, looking down from straight across, right? Now let's label the side. So again, he's 2 miles away from the launch pad. Here he's 15 miles up high. We're trying to find this angle. Now the beauty of this angle, if we think about it, is it's parallel with the ground, meaning it's equivalent to this angle. It's an alternate interior angle situation. So if I just call this angle theta, I'm really solving for this. So now thinking about SOHCAHTOA, the question is, what does this side and this angle have in common? Well, it's opposite and adjacent. Opposite and adjacent are right here relative to theta. So I can say tangent of theta is equal to opposite over adjacent. And to solve for this angle, I take arctangent of 15 over 2. So let's do that now in Desmos. And we get 82.4. So the angle of depression is 82.4 degrees. Boom, done. Isa is standing 10 meters away from a 6-meter tall building. Travis is looking at the top of the building, looking down at Isa. At what angle is Travis looking at Isa? So here we have the 6-meter tall building, and here we have 10 meters away, and this is where Isa is, and up here is Travis. So of course we got this nice right triangle, and then we want to know what angle is Travis looking down at Isa. What is this talking about? This is talking about an angle of depression. So I can extend this sort of imaginary horizontal line of view out, and the angle of depression is going to be this angle here. But it's outside the triangle. So I'd ideally like to solve for something inside the triangle, and guess what? Since this line is parallel with the ground, it has to be, okay? Then by alternate interior angles, this is also theta. So I can just solve for this angle and we're good to go. So thinking about SOHCAHTOA, okay, and that angle and the sides that we know, I see the opposite and the adjacent side relative to that angle. That's TOA, that's tangent. So let's use that function. Tangent of theta equals opposite over adjacent. And then to solve for this, I'm going to take arctangent of both sides. So we're going to take arctangent of 6/10. Let's find that in Desmos. And we get 30.96, which rounds up to 31.0. So 31.0 degrees, boom, done. A 90-foot tall building has a shadow that is 2 feet long. What is the angle of elevation of the sun? So this is a very interesting question the way it's phrased, but we know that we got a 90-foot tall building and we know we got this little 2-foot shadow. It's exaggerated, obviously, right? Like 2 feet would be much smaller if this was drawn to scale, but it's all good. We got a right angle here, and when they say angle of elevation of the sun, this is my angle of elevation. So it just sounds weird because the sun's coming down, so like you're usually thinking angle of elevation looking up, but all good. Okay, now the question is, what trig function do we use to solve for theta? Well, for theta, I have opposite and I have adjacent. Opposite and adjacent is tangent. So I'm going to take tangent of theta and set it equal to opposite over adjacent. And then to solve for this, we're going to take arctangent of both sides. By the way, 90 over 2, I'll simplify that to 45. Now let's check it in Desmos. And our answer is 88.7. So we get 88.7 degrees. Boom, done. A spotlight on the ground 3 feet from a 5-foot tall woman casts a 15-foot tall shadow on a wall 6 feet from the woman. At what angle is the light? So this one is all about the diagram, okay? So here we have the light on the ground, and then it's 3 feet. So this little distance here is 3 feet from my woman, and the woman is here, okay? And the woman is 5 feet tall. And then it says it casts a 15-foot tall shadow. So this is the shadow in the background on the wall that is 6 feet from the woman. So this distance here is then 6 feet. And then it says at what angle is the light, meaning what's this angle in here? So we got a lot going on. Now, what this means is we've got two separate triangles, and we can use either of which to calculate this theta. So just for fun, I'll do it with the big triangle, and then the question is, what trig function do we use? So I'm going to write out SOHCAHTOA, and if we're talking about this big triangle, what I know is the opposite and adjacent side to this theta value, which means we're using tangent, okay? Opposite, adjacent. So I got tangent of theta equals opposite, which is 15, over adjacent, which is these two together, which is 9. So to solve, we're going to take arctangent of 15 over 9. Let's do that in Desmos. So here we get 59.03. So that rounds to 59.0 degrees. That's how you do it. Done. A person does a handstand with her feet touching a wall and her hands 3 feet away from the wall. If the person is 5 feet tall, what angle do her feet make with the wall? So here we've got the distance from the wall. This would be the wall, right? So that's our 3 feet. And then the person is kind of leaning this way, leaning again diagonally against the wall. So that's 5 feet. And we're trying to find what angle do her feet make with the wall. Again, she's doing a handstand, so her feet are up here, right? So this is the angle we're trying to find. So then if we look at SOHCAHTOA, the question is what angle or what trig function makes sense with this angle and these sides? Opposite and hypotenuse. That's sine. So we get sine of theta equals opposite over hypotenuse. Now to solve this, we take arc sine of both sides like so. And to do this calculation, we're going to use Desmos. So there we go. We get 36.9 when we round up. Don't forget to be in degrees mode. So the answer is 36.9 degrees. Boom, done. I hope you guys enjoyed this video. And if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.